All right then, let's get started. Hello everyone, my name is Kyle Knapp, and I'm a software developer here at AWS, where I primarily focus on developing the AWS command line interface and the AWS SDK for Python, also known as DEV402. And I'm going to talk to you today about what it means to be an effective AWS CLI user and how you can become one. To start, this talk's going to be advanced, so I'm not going to go over a lot of the basics of how to use the AWS CLI or the basic usage patterns. I'm making the assumption that you are already familiar with these, which will allow me to dive into more advanced topics. In the case you're not too familiar with the AWS CLI, here's some few links you can look into. And of course, the slides will be online later for reference. So let's get started. The AWS command line interface. It's a unified command line tool for managing your AWS resources and interacting with the various different AWS APIs. And when I think of what it means to be an effective AWS CLI user, I think of 4 tenets. First, the effective AWS CLI user uses an iterative workflow. So they take a step-by-step approach to figuring out the commands they need to run, what parameters, in order to accomplish a task. And once they start feeling comfortable, they take that next step, trying to combine commands together and build shell scripts off of those commands. They troubleshoot well. When they get results they don't expect, they are able to figure out why they're getting those results and able to resolve those issues. They're resourceful with tooling, so they take functionality outside of the CLI along with the CLI to build functionality that they may need. And finally, they understand performance implications. They understand how some of the more complex commands work in CLI and how changing parameters and configuration values actually affect that performance. So in order to illustrate these tenets, I'm going to go over a sample application we're going to be building throughout this session. And in the sample application, I'm going to be taking Amazon VPC to create a virtual private cloud. Then I'll be using Amazon EC2 to launch instances into that VPC. I'll be using IAM to create roles for that instance, such that the EC2 instance can then get temporary security credentials and upload files to S3. So taking an architectural view of what we're building, here's the AWS cloud. We're going to first start off by creating our VPC. Each VPC comes with a built-in route table. We'll then create a subnet. We'll create an internet gateway and attach it to our VPC so it can communicate with the outside world. And then we'll create a security group. We'll launch EC2 instances with an IAM role. And using that IAM role, the EC2 instances can upload files to S3. So let's start talking about the first tenet, which is the effective AWS CLI user uses an iterative workflow. So here's a sample CLI command that a general CLI user may run, where they specify the service, they specify the operation, and a set of parameters that they need to provide. They then get a JSON response back from the service, and based off the application they're trying to build, they'll then use components of that response for subsequent commands. So for example, we're going to be using VPC ID a lot because a lot of the resources depending on that VPC. So they would go ahead and copy and paste that value into a command, or even if they're savvy, they'll save it to a bash variable or so. I want to make the comment, we can do better. We can do better because if we're trying to take that next step, trying to build shell scripts off of the commands we ran, we need to do this in a programmatic way. There's still a manual step of copying and pasting that actual value. Here's a better way of writing this command. We're still calling the EC2 create VPC, but instead, now we add parameters such as query to use a James path expression to query down the specific value that we may need, which is VPC ID. And then we use output text to actually strip off the double quotes so that when we now echo VPC ID, it will be the correct value. Another way of doing it is by running the entire command and then saving the entire output and using command line tools like JP, which is a James Path command line tool, to get the same functionality as query and output. I want to make the statement, we can even make this better. So in order to understand how we can make it better, we need to understand what the problem is. The problem is we don't necessarily know what the output is going to be ahead of time. We have to guess based off prior experience or based off the help documentation, or go ahead and run the command and save the entire response and try to work your way from there. What would be better is if we can get a sample output to work with that we didn't actually make that API request and have a lot more confidence in the command we're about to run. So what I want to show you now is a new feature that we launched yesterday in the latest in a CLI release that allow us to do that. Cool. So I'm going to go ahead and type out EC2 create VPC, provide a CIDR block, and instead of running this command, I'm going to add the generate CLI skeleton parameter. If you're familiar with this parameter, providing no other positional arguments to that parameter, it'll print out a sample input, which you can then use for the CLI input JSON parameter. The extension we added to this parameter is the output extension. So if I type output here, I can actually see what a sample response would look like. Furthermore, I can then apply the query parameters that I want to actually figure out what specific value that I may need. So I'm going to query for the VPC, and then I can get the VPC ID, and can continue to iterate till I get the exact format that I want out. So this looks like something we want to work with. And now I can go ahead and remove the generate CLI skeleton parameter and actually make that API call now that I feel confident about the command. So that now if I echo that, it should be correct, which it is. So this is a really handy parameter to use, mainly because it can give you a lot more confidence in the command you're about to run, the query, the output you're using. And when you have this scenario where you're creating a lot of resources, you don't want to be making the unnecessary API calls, because if you messed it up and trying to make a programmatic way, you have to go back and delete the resource and try again. So now what I want to do is talk about how we're able to do this, how we're able to rely on this sample response. So here is the output from the generate CLI skeleton with the output option. And the reason we're able to do this is because the CLI relies on an underlying library, also known as BodoCore. BodoCore is the library that powers the AWS SDK for Python and the AWS CLI. BodoCore is completely data-driven, such that all of its methods, all of its parameters are driven off API models representing the various different AWS API. And here is an example of one of those APIs. And you can see that when you start looking at the sample response compared to the output for create VPC, its model, you can see how they start matching up, such that the outer members match up with the outer members, and the inner members, such as VPC IDs, as well match up. So having this direct translation, we can accurately have that as a sample response, because the output accurately represents what's coming back from the service. And therefore, we can reliably use query and output. So now that I talked about the generate CLI skeleton output, let's continue on with our sample application and build a few more resources. I'm going to be showing you a few more tricks in order to accomplish that iterative workflow as well. So to show you one more time how generate CLI skeleton with the output option works, let me start using it for the create subnet command. I have to pass in a CIDR block. I have to pass in a VPC ID as well. And before running this command, I'll go ahead and put out the generate CLI skeleton parameter with the output option. And from there, I have a quick reference in order to create my James path query. and figure out the output. This looks like the response I would need. So I'm going to go ahead and remove the generate CLI skeleton parameter with the output option to go ahead and actually make that API response. And now if I echo it, it should be correct, which it is. Cool. So now what I'm going to do in order to speed this up a little bit is show you some sample commands that I built up using the generate CLI skeleton. I don't need to show it to you. I feel like I've given you the gist of how it works. So I'm going to open up this spare file and go ahead and copy it and run it in the terminal. So all I'm doing is I'm creating a gateway. I'm attaching it to the VPC. And I'm just describing what the table ID is for my VPC that got built with it. So now the very last step I need to do is go ahead and create a route. And in order to create a route, I need to call the EC2 create route command, which accepts a route table ID, destination setter block, and finally, you need the gateway ID. So before running this command, what I'm going to do is actually prefix it with echo. And the reason I'm prefixing it with echo is because I haven't been checking any of the bash variables that I have, and I don't want to run this command and have a mess up one of my variables. So now if I actually look at how it got substituted, I can see how the table ID got substituted correctly, and also the gateway ID also got substituted correctly as well. So I'm pretty confident about that this command is going to work, so I'm going to go ahead and actually run it. And return true, which looks like it worked fine. So now let's take that next iterative step of creating shell scripts. The fact that we did this all programmatically, it makes it really easy to start actually having a basis for our shell script. So now I'm just going to use the history command to actually get the previous commands that I have been running. I'll strip out the line numbers as well. And now if I open it, I can see all the commands that I have run. So I can go ahead and just start removing some of the commands I don't need, such as the generate CLI skeletons. I can remove the echo, some more of this generate CLI skeleton. And eventually, I can get down to the set of commands that I need to actually run to get this working. And the fact that I've already ran these in a terminal, I know that this is going to work. And from there, if I want to, I can continue iterating on my shell scripts such that I can add the VPC ID if I want to echo that out. I can add a shebang to the top. I can add some error logic into there as well. But you all get the gist of how easy it was from taking a programmatic approach to writing CLI commands. It was to actually start writing shell scripts. So in order to incorporate an iterative workflow, some recommendations that I have are use generate CLI skeleton with output. It's a way for you to play around with the command and get sample responses to kind of get a gist of what you're going to get back. And once you have a lot of confidence, you can go ahead and run the command with more confidence that it's going to work the way you expect. Also, don't forget about Unix commands such as echo to make sure you're checking how your variables are getting replaced. And if you took the programmatic approach to writing your commands, you can easily write shell scripts off of them using the history command. So now what I want to do is talk about the second tenet, which is the effective AWS CLI user troubleshoots well. So here's a command that many of you in the room have probably run, where you ran the command and you got an error back saying you're missing a required argument. Or you ran a command like this and you had specified an invalid resource ID. For the most part, CLI exceptions are self-explanatory, but for some exceptions, you may not understand how you're getting them, and you need some deeper insight into what exactly is going on with your CLI command. And that is where debug logs come in with the debug parameter. So when you add debug to the end of the command, or anywhere in the command, it will print out a set of log messages. The log messages represent how the CLI is processing that command. And these log messages continue on. They actually continue on for a long time. And they're overly verbose for the purpose of CLI developers like myself to be able to understand what the CLI is doing under the cover. And fortunately, for the general CLI user like yourselves, you don't need to understand most of the debug log messages. There's only a handful set of debug log messages that will give you that insight you need to debug your CLI command. And in order to understand debug logs, you need to have a brief understanding of how the CLI stack works. So I'm going to start walking through that. At the very first step of a CLI command, there is the parsing of the command, so determining what operation, what parameters got passed in. After the command gets parsed, a Botocore client call gets made. Botocore, if you remember from before, it's that underlying library that powers the AWS Python SDK and the AWS CLI. So you can see how it translates. So you see how the operation command gets translated to a Botocore client method, and how the parameters also get mapped to method parameters as well. So once the method call has been made, then you get a response back. And with that response, the parameters such as query and then output are then applied to actually get it into the format that you may need. What I want to do now is focus on what's happening under Botocore. The very first step that happens is Botocore will validate and serialize the parameters passed to the method call. So you can see on the right here, there is a sample model for create security group. And has a bunch of information related to the input, such as the valid parameters you can pass in, what their types are, and even what's required. So using this information, Botocore will validate it and then serialize it down to an HTTP request. It'll then send that request, and a response will be received back. And with that response, Botocore will then use the output of this model, you notice the create security group result, to actually get it into a format that the CLI could consume. So now back to debug logs. One point you need to understand is that debug logs, they follow the same direction as a CLI stack. So log messages that happen at the very beginning of the stack correspond to the beginning of the debug logs, and debug log messages at the end correspond to the end of the stack as well. So now let's actually look into some debug logs at different parts of the stack. So here's a sample command that I've put up. And looking at the parsing of the command part of the stack, one log message that I really like using is the arguments entered into the CLI. While this may seem obvious, it's particularly useful if you're using bash substitution, so that you can actually see what the literal value passed in is. Another log message that I like looking at is when you use file parameter notation. So when you want to express the contents of the file with a file : / notation. So when you first look at the arguments entered, you'll notice that it hasn't been parsed yet. But later down in the log messages, you can actually see what the contents of that file were and figure out what value you're actually passing to that API call you're making. Once you get to the validation and serialization part of the stack, one log message I like looking at is the making request. So this has a lot of information about the request you're about to send over the wire. For example, there's the operation, there's the parameters you're going to pass in, and even the URL that you're going to send this request to. Furthermore, once you get down to the HTTP request and response part of the stack, this is a smaller log message, but it's actually quite important because it tells you what the HTTP status code was of your request, so it tells you if it was successful or not. You can also figure out what the literal body of your CLI commit of your response was. So you notice here on the right that this is XML. This is what EC2 returns to us in the CLI. The CLI actually parses this XML and returns it into that JSON document back. So this hasn't been touched by the parser at all. And you can see some of the untouched values, such as the return, the group ID, and even some values that get parsed out, such as a request ID. You don't see that in a CLI, the response to a CLI command. And finally, one log message to look at is the retry handler log message. So it tells you if your request got retried at all. In our case, there was no retry that happened. So now what I want to do is take the knowledge that we just learned and actually apply it to a sample debugging scenario. And the sample debugging scenario will be related to creating our security group. So let's say we were working on our application, and we were about to create our security group, but our boss pulled us aside and told us we needed to go tend to some resources in a different region. Currently, the region we're working in is in US West 2, and these resources are in US West 1. So I'm going to go ahead and set my region to US West 1. And let's say this was a Friday, and you tended to the resources, but you never got back to actually creating a security group. So you come back into the office on Monday, and you get right back to it. If you didn't remember to set your region to US West 2 now, and go ahead and type the EC2 create security group command by providing a group name, a description, and also the VPC ID. You'll get this exception back saying you couldn't find your VPC. At that point, you may be confused. I was just using this VPC. Why doesn't it exist? Why can't I find it anymore? I didn't mess with my bash variables at all. I wonder if someone went and deleted my VPC over the weekend. At that point, there's two options you can look into. First, you can call the EC2 describe VPCs command to see if your VPC actually exists. Or you could go ahead and just rerun the command, but this time with debug. And when you print out debug, you'll see there's a lot of log messages. I personally don't like using standard error to look through these log messages. I personally like piping it to a pager such as less. Because what that'll let me do is jump around in lines and actually search for specific parts of the debug log messages. If you remember from that command, we got an exception back, right? So whenever there's an exception and you're looking at the debug logs, there will always be a traceback. So that's the very first thing that I always search for when parsing debug logs. And you can notice that the traceback in this case is at the very end of our log message. So if you remember the stack, this is happening in the parsing of the response. And when you start looking into this, you notice that this error is getting raised in Boto-core clients. So that makes sense since it's in the parsing of the response under the make_API call. And it is purposely raising a client error based off a parsed response. So that's telling me Boto-core is purposely raising this error because of the response returned to it. So now if I scroll up to the actual response, the HTTP status code, I notice that it's actually a 400 I got back. So my assumption was right. So that's telling me my request was off. So scrolling back up and looking at the making requests part of the debug log messages, you can actually start seeing that information and checking to make sure it's actually correct, such as the create security group operation looks right. I continue to scroll. This VPC ID value, that looks like a proper VPC ID. And finally, when you get to the URL, you realize this URL looks wrong. This is pointed at US West 1. And then you realize, oh, I forgot to set my region back to US West 2. And that's why I'm not able to find my VPC, because US West 1 doesn't know about my VPCs in US West 2. So with that knowledge now, I go ahead and reset the region. And I'm actually going to go ahead and run the command. And I'm going to put the query in ahead of time because I already know that. And save its value. So now if I echo it, it should be correct. which it is. Cool. So thanks to our debugging knowledge, we're able to figure out why we couldn't find our VPC. So now let's talk about the key takeaways from that section. So in order to become better at troubleshooting, make sure you use debug logs. They'll have a lot of information of what the CLI is doing, and you can use that to figure out what your command and why you're getting the results you are. If it's an error that you're getting, always search for the traceback. When you search for the traceback, you figure out where that error is getting raised, and then from there you can work your way up the debug logs with your knowledge of the AWS CLI stack to actually figure out what initially caused that. So now, let's talk about the third tenet, which is the effective AWS CLI user is resourceful tooling. So when I think of resourceful tooling, I think of using functionality outside of the AWS CLI, such as bash, Unix commands, and external tooling like JP, that James Path command line tool, and some of the interactive tools like JP Term and AWS Shell. I would really recommend watching last year's CLI reInvent talk if you want to learn more about this. It goes into great depth about how you can combine these. And what I want to do now is focus on this do-it-yourself aspect of tooling. And in order to talk about this aspect, I want to go over a brand new feature that we released just today in the CLI. And I'm really excited about it. And this feature is called aliases. So I'm really excited about aliases because I feel that it's going to make CLI users across all skill groups a lot more productive as a CLI user. So CLI aliases are very similar to Git aliases, where if you specify in your git config a shorthand command for a longer command, you can run this shorthand command, and Git will be able to translate it to the full command name. So git co some branch becomes git checkout some branch. So I can go ahead and talk about this in slides, but actually what I want to do is actually go through demo and actually show you how you can build up aliases and all the really cool functionality that you can get out of aliases, and how that can really improve your productivity as a CLI user. And in order to illustrate this, we're going to go back to our sample application and create our EC2 instance and our role and launch those. So to give a brief introduction of how aliases work, I'm going to share with you a command that I really like. It's the sts get caller identity command. The reason why I like it is because it tells me what user actually made that request. Specifically, it gives me a lot of helpful information, such as the account ID. That account ID is useful for creating ARNs, for granting permissions, for creating policies. And the only other way to get it would be to log into the console. You can find your account ID there, or even try to parse a resource ARN out you have. So having this on the back of your hand would be really handy and a great candidate for an alias. So in order to add it as an alias, you have to open up the AWS CLI alias file. And you'll notice there's a top-level section here. You need that for all alias files. And if I want to actually add an alias for this, who am I essentially see this command as a who am I for AWS services. And all I need to do is specify my commands I want to run. And all I have to do now is type AWS who am I, and it'll give me the same response back from get caller identity. Furthermore, like get aliases, you can add any set of parameters that are valid to that command onto that alias. So if the account ID is all I want, I can go ahead and put the query for account, and I can also apply an output text so I get that unquoted account ID back. So now if the account ID is all I care about, I can go ahead and iterate and add those parameters to my alias. So I can put my query. So that now, if I call AWS who am I just get that unquoted account ID back. So now that I gave you that brief introduction of how aliases work, what I want to do now is show some of the deeper functionality that you can get out of using aliases. So going back to our sample application, we're going to go ahead and create our role to start. In order to create a role, the first thing we need is a role name. So I'm going to call mine reInvent. And we also need a trust policy. So I have a trust policy on disk. And my trust policy says it allows EC2, the service, to assume that role. So if I want to go ahead and actually create a role, I have to call AWS IAM create role command and specify that role name and the assume role policy document. I'm going to use the file parameter notation in order to reference that trust policy now. So I'm not actually going to run this command. I just want to make the point that I think this is actually would be a good candidate for an alias. And it's a good candidate for an alias for two reasons. One, in order to run this command, you always have to reference the file on disk. You have to know where that file is and then be able to run that command from there. Two, if I wanted to have a different service to be able to assume the role, I would have to go in and modify that file. It'd be nice if I could specify what service I want to assume that role. I went ahead and actually created an alias for this specific purpose. So the alias I created is called create assume role, where all you have to do is pass in a role name and the name of the service you want to create that role, or allowed to assume that role. So when I run that alias now, I'll get the response back from IAM create role. So you can see how I have the assume role policy document in here and the role name of reInvent. So now let me actually show you what this alias looks like. So as I said before, you'll notice a few things. I'm still calling IAM create role, but the CLI command is wrapped by a bash function, which is then prefixed by this exclamation mark here. The exclamation mark is important because it indicates to the CLI that in order to run this command, run it as an external command in a subprocess of your shell. And what that lets you do is take advantage of a lot of the functionality that your shell provides, such as bash functions. I use a bash function because then I can then map positional arguments to my CLI command. So I map the first positional argument to the role name, and then I map the second positional argument to actually fill out the assume role policy document. You'll notice that in order to have a variable assume role policy document, it's hard-coded, and there's a lot of escaping of double quotes. I didn't do this by hand. You should not do this by hand. It takes a long time, and you're going to make mistakes. Instead, what I used was JP. And if you specify the file name, trustpolicy.json, and then use a James path expression toString, it will actually escape the quotes for you, as it's just converting the entire JSON document into a string. So that is the exact value I used. And in order to continue on with our sample application, we need to now figure out what policy we want for that role. Specifically, we need S3 to have S3 permissions for it. So in order to figure out all the policies available to me, I need to run the IAM list policies command. And when I run this command, you'll notice a few things. There's a fair amount of policies available. Most of them are not even related to S3. So you probably would want to do a query for policy names containing S3. Furthermore, the list policies command doesn't actually say what specific policies you're granting. You would have to use the get policy version command in order to determine that. And while the names are self-explanatory for the most part, it would be actually nice to know what permissions you're granting. So for this specific use case, I actually created another alias called search policies. So all I have to do is provide a positional argument. It'll search for all the policy names that contain that argument, and also print out the document as well. So now when I run this command, I can see all the S3 related policies, such as the Amazon S3 read only. You can see the document as well. You can see there's an S3 full access, and there's even some server-specific S3 related policy. For the purpose of this session, I'm going to use the the full access policy. So I'm going to go ahead and save that policy arm. So now what I want to do is actually show you what this search policies alias looks like. So the reason why I want to show you this alias is to show you that you can have more than one CLI command in an alias. You can have entire bash scripts in your alias, or whatever your shell supports. So I'm not going to go into this too deeply. There's a lot of complex James path queries I'm doing here. But I originally called list policies command, and I searched for all the policies that contain that first positional argument that I passed in. And then I use further James path expressions to get into an output format that I can then pipe into the get policy version command. And using the get policy version command, I can get all the documents, the specific document for that policy version. So now let me go ahead and real quickly attach the policy to my, attach that policy to my role. And I need to provide a policy yarn. So I'm all set up now in terms of my role. The next thing I need to do is create an instance profile for my EC2 instance in my role. So in order to speed this up, I create another alias called setup instance profile that all it does is take a role name, and it'll create an instance profile and add that role under the same name. So you can see how I just created a reinvent instance profile. So we have all the resources now to actually go ahead and start launching our EC2 instances. So for the purpose of this demonstration, I created another alias, surprise, called the launch reinvent alias. And the launch reinvent alias, it's different from other ones in the sense that I'm not using an external command. You notice there's no exclamation mark. So I'm using the subcommand run instances. And the reason I have an alias for this is it shortens the amount of typing I'm going to have to do for future commands, so that I don't have to remember what the image ID was. I don't have to remember what my key name is, or even that James path expression when I query. So now that all I have to do is provide all the variable parameters. So parameters such as the instance type. There's the security groups. There's the IAM instance profile. And finally, I just need to provide the subnet ID. So now let me go ahead and save the instance ID. So all I have to do is echo it out to make sure that looks correct, and it is. So now that I have an instance that's getting launched, I'm going to go ahead and spin up a second instance for the sake of the next demonstration. This instance is going to be a bit larger. So now let me check to make sure that this is correct as well. And it is. OK, so as these instances are getting launched, let's go back and talk about the key takeaways from this section. So in order to be more resourceful tooling, I highly recommend trying aliases. Aliases are going to make you a lot more productive for multiple reasons. One, it's going to reduce the length of the commands you're typing. Two, it's going to reduce the complexity. You can store default parameters. You're going to be able to wrap shell functionality inside of your CLI commands, so all you need to do is run a single CLI command to access that functionality. And finally, one thing I want to note is that if you notice this alias file, it's separate from your credentials, it's separate from your config file. And this was done on purpose. It makes it a lot easier to share aliases with other coworkers, with fellow CLI enthusiasts, as you don't have to worry about leaking your credentials or your configuration. And on the same note, the CLI team has recently launched a GitHub repository with sample aliases. So actually, let me open that up real quick. So the alias repository is under the AWS Labs org, and it's called AWS CLI-aliases. So this is a brand new repository, as this is a brand new feature. So we're going to continue adding more aliases to this repository. And these aliases that we filled up are ones that we use in our everyday work. So it's going to already increase your level of productivity there. And another point I want to make out is that this is on GitHub. It's an open source project. So if you come across a really cool alias that you think is going to be really helpful for the rest of the CLI community, go ahead and send a pull request, and people can start picking up aliases right away and start using the productivity or the functionality that you created. So now that I talked about that tenet, let's talk about the final tenet, which is the effective AWS CLI user understands performance implications. So when I think of understanding performance implications, I think of 3 different areas in the CLI. There's client-side, server-side filtering, there's pagination, and then there's also the S3 commands. So let's talk about client-side and server-side filtering to start. Here's a sample command a CLI user may run. What they're trying to do is describe to them all the Amazon Linux HVM AMIs. And they do so by specifying the query parameter. So if you remember from the second section about in the troubleshooting section about how the stack works specifically for query, you would remember that query gets applied at the very end of the stack. So this is after the request has been sent, after the response has gotten back, and even after the parsing. So by running the command like this, you're actually listing out all the available images to you and then performing that client-side filter, which, as a result, causes the command to be slower than it needs to be. A better command to run would be to use server-side parameters, such as the filter parameter, to go ahead and let the service API go ahead and filter it out for you. And then from there, you can use client-side parameters to actually filter out what you may need at the end. And by running it like this, you greatly increase the time for that command to run, or decrease the time it takes. In general, you want to make sure that you're using server-side parameters whenever possible, as if you put it all in the query, it's going to take longer than it needs to. So now what I want to do is talk about pagination. So if you're unfamiliar about pagination, here's an example command that is paginated by default. It's a describe snapshots command. So the way pagination works in the CLI is the CLI will make the describe snapshots API request. And based off that request, it'll get a response back with the list of snapshots available to the user. If there's any more available snapshots that can be described, it'll return an output token. The CLI will detect this output token and then use it as an input token for a subsequent request to get the next set of snapshots. And the CLI will keep doing this until there's no more output tokens coming back from the service, indicating there is no more snapshots to be described. Once all of these responses are collected, they are then merged into one big list of snapshots. So the behavior of pagination can actually change based off the parameters you pass in. So here's an example of how the behavior can change with the output parameter, specifically the text format. And when you specify output text, you still get all of the snapshots. But instead of actually waiting for all the responses to come back, the CLI will output each response as it comes in. And you get more of a streaming effect here. So if you have the workflow where you're trying to describe a set of resources and then perform an action on that set of resources, you want to make sure you're using the output text format because that will increase the concurrency. So for example, if I wanted to share my particular snapshot with an individual user, if I didn't provide output text to my parameter, I would have to wait for the entire command to run before I can start sharing my snapshot. And therefore, by providing output text, you'll speed up the length of your shell scripts and commands. So now the one last area I really want to focus on for this part of the talk is the S3 commands. So with the S3 commands, here's a sample architecture of how an S3 command looks. There's always a thread. For all S3 commands, there's always a thread pool backing it. And these threads, what they do is they contact S3 and upload or download data to and from the cloud. So when we're doing an upload, the first thing the command will do is determine if the file needs to be multi-part uploaded. And if it does, it will break the file up into parts. And it will put each part into a task queue, so that threads will then start pulling parts off this task queue and start performing the upload. And as each thread finishes, it will pull another part off and continue to perform the upload part. And then once there is no more parts left, it'll then call a complete multi-part upload to actually finalize that S3 object. So in order to talk about performance related to the S3 commands, there's 4 different parameters that you can set that affects the performance. Note that these parameters, they only affect the S3 commands. They don't even affect the S3 API ones, as those are generated from the API model that S3 provides. And the parameter I really want to focus on right now is the max concurrent request, because that has the most performance implications. And when you go back to the architecture, max concurrent request directly translates to the number of threads in your thread pool. So increasing the max concurrent request, that will increase the potential bandwidth you're using, and decreasing it will decrease the potential bandwidth as well. So in order to illustrate this, I'm actually going to complete this final leg of our sample application and upload files to Amazon S3 from our EC2 instances. So by now, the EC2 instances should be ready to be connected to. One thing I have to do before I actually can SSH onto my instance is authorize my IP for that security group. I want to note when I'm actually running this alias, I am not actually opening up to the world. I'm only using my specific IP that I know about. And now if I want to actually connect to my EC2 instance, I have another alias to do that, and it's called connect SSH. So I'm going to go ahead and connect to that first instance I created. So on this EC2 instance now, I have a few things installed. I have the CLI installed and a few files laying around. And to show you how S3 upload works, let me go ahead and run a command. And if you're a long-time user of the CLI, or specifically the S3 commands, one thing you may notice in the minor version bump 1.11, that a few things changed in behavior. So one change was we moved off of the part notation when expressing progress to a specific value in terms of bytes. And in the recent release of the CLI that released aliases, released one more feature, which is transfer speed. So you can see on the right here, this is the actual transfer speed of your CLI command. So one approach to actually figuring out what's a proper max concurrent request would be to try to upload a file and figure out what max concurrent request gets you the highest transfer speed possible. If you're actually trying to do this for multiple environments, this would be tedious. If it was only for one environment, it might not be bad. But in the case that you're spinning up the AMI for different sizes and different environments, it'd be nice if it was more automated. I actually wrote a script that would do that as well. So in my script, what I do is I set it at a very low setting of 1 max concurrent request. And from there, I actually track what the transfer speed is by running the CLI command in a subprocess and parsing through the standard output. And after polling for 10 seconds, it will then suggest a new max concurrent request. And from there, it can actually start determining what max concurrent request it should try next. So you can see how when it went from 1 to 4, it noticed a big increase, so it tried 4 to 7. But then when it went from 4 to 7, though, you'll notice that it didn't increase as much. One thing you need to realize is that for all environments, you're limited in your resources. So once you start hitting that bandwidth, throwing any more number of threads into your transfer is not going to increase the amount of bandwidth you have available to you. So picking the max concurrent request size that's correct or more suited for your environment is quite important. So now let me hop off this EC2 instance and hop onto the other instance that I spun up. And if you remember, this EC2 instance was a larger one, so it has more bandwidth available to it. To make it easier for me to configure this, I actually added another alias that calls out my Python script that I wrote, and I called it AWS autoconfigure. So now this is going to be doing the same thing as last time, where it starts off at 1 and tries to track the transfer speed. And as it's tracking the transfer speed, you'll start noticing once it hits the 4 that the actual transfer speed for 4 was a bit higher than it was for that smaller instance. So once it's tracked for 4, you notice that when it makes that jump from 4 to 7 now, the bandwidth is still pretty high. You notice that it hasn't reached that ceiling yet in terms of bandwidth usage. In fact, it didn't reach, even though it didn't reach it, it suggests the maximum value increase even more. Right now, for my script, the maximum jump I can make is 3. So even when going from 7 to 10, it still noticed enough increase to try a different value in terms of 11. And in the end, it actually decided to stay with 11. And the one point I really want to make here is that if I had stayed with 7, I'd be missing out on potentially a lot of bandwidth. And if this transfer speed is important to me, knowing about that max concurrent request value, what's appropriate for your environment, is quite important. So, oops. Now let's talk about the important takeaways in terms of understanding performance implications. So first, I talked about server-side and client-side filtering. The takeaway there is always use server-side filtering when possible. I also talked about pagination. If you're trying to have a workflow where you're describing resources and then performing action on them, make sure you use output text and pipe those commands together. And finally, I talked about max concurrent requests and how setting that can actually affect your performance speed. And finding that specific value you need is important. So now that I talked about all the tenets, what I want to do is summarize what I talked about. So I talked about the effective AWS CLI user, and I gave a lot of practical examples of how you can implement or follow these tenets in your everyday CLI use. So in terms of using an iterative workflow, I talked about how you can use generate CLI skeleton with the output option to go ahead and get a sample response to play with and give you a lot more confidence before you're actually making that API request. There is troubleshooting well and using debug logs to get that extra bit of context you need for understanding what your CLI command's doing. In terms of being resourceful tooling, use aliases. Aliases are going to make you a lot more productive, and it's going to improve your CLI workflow. And finally, in order to understand performance implications, I talked about S3 and how that affects transfer speeds. So I really hope you enjoyed this talk. Make sure you complete your evaluations. And I want to thank you again. But wait, before we pause, I want to make the note, if you want any follow-up information, please follow the AWS developer blogs. We'll have a blog post summarizing what I talked about and some extensions on top of it. If you're a Twitter user, you can follow me at vcalnap. I will post information as follow-up information comes up. And also make sure to check out the aliases repository. It's brand new, so we're going to continue adding new aliases. So continually stop by to pick up some new functionality that's going to really help with your CLI development. And thank you again.